Hello guys, welcome to a new video, and in this video we are just going to go over um, section 6.0 of the CCNA security exam, which is for the IPS. Um, and we are almost done, as you can see, with the CCNA security exam, and I have gone over section 1 through 5, all of them. And if you want to see any of those videos, you can go ahead into my YouTube video or to my YouTube channel where I have all this great content that I have created for this CCNA security exam that has helped me, and hopefully it is helping you as well to learn about this certification and learn how to configure and learn all these new protocols that you could see for this CCNA security. So I'm just going to go ahead and go for section only 6.1. On another video, I'm going to do section 6.2. So let's go ahead and talk about IPS and their um, tools. So So we are going to describe IPS deployment considerations. And the first thing that we need to know, we need to learn about the network-based IPS and also the host-based IPS. And the network-based IPS involves the deployment of monitoring devices or sensors throughout the network to capture and analyze traffic. Sensors detect malicious and unauthorized activity in real time and can take action when required. So that's what IPS does. It detects and also protects. Okay, and sensors are deployed at a designated network points that enable security managers to monitor network activity while it is occurring regardless of the location of the attack target. Okay, so a network IPS sensors are usually tuned for intrusion prevention analysis. The underlying OS of the platform on which the IPS software is mounted is stripped of unnecessary network services, and essential services are secure, means that it is hardened. Okay, and that is what a network-based IPS is. Network-based is uh, is a device or a sensor that is put in the network to capture and analyze the traffic. Okay, and it also protects you. So what the IPS does, uh, it gets it, it detects it, and then it also protects you. And a network base, the hardware includes the following: a network interface or card or a NIC. A network IPS must be able to connect to any network Ethernet, fast Ethernet, or gigabit Ethernet. The processor of the network base intrusion prevention requires CPU power to perform intrusion detection and analysis and pattern matching as well. For the memory, intrusion detection analysis is memory intensive. Memory directly affects the capability of the network IPS to efficiently and accurately detect an attack. So based on your network, you should know what IPS you're going to put in. If you're going to put a network-based IPA and you get a lot of traffic into the network, you got to make sure that the CPU is very powerful if you get a lot of traffic, and the memory as well is very large. And hopefully it's a gigabit Ethernet as well, so it doesn't interrupt your traffic, and more if it is voice as well, because that could cause the voice to lag in your network. And host IPS, host-based IPS. A host-based system protects a unique host by attaching itself closely to the operating system. So as you can see, the host base is on the operating system of a computer, so it is inside a computer. So it is for every host that you need to install it. And the network base is just when you plug it into the Ethernet cable, and it is part of your network. Okay, so it is closely to the operating system kernel and forming a layer which filters all system calls as well as application call and allows only call which are legitimate to go through. Um, there can be four types of host-based intrusion detection system name. Mm, And the name advantage, the main advantage of using the host-based prevention system is that since the protection system is integrated with the host itself, so with a computer, it is very easy to point out whether the actual attack has been successful or not. This is very vital piece of information which is not easily obtained in the network-based protection mode. Also, it is very difficult for a hacker to get past the host-based protection system using fragmentation attacks. And one of those like applications is the Windows firewall, but everybody knows that the Windows firewall doesn't protect you at all. And here are some host-based IPS that you can use. We have McAfee, of course, Trend Micro, Hillstone, Dark Trace Enterprise, NS Focus, NGIPS. We have H3C. We have the this NIP. Then we have the Intrust, IO Trust Identity and Data Security, and of course Cisco Firepower, NGIPS, and IDPS vendor. And there's a chart that I didn't include there. And also here's the advantage and the disadvantage of having a host and a network IPS. The advantage of the host IPS, that's what it means when you do an IPS, a host IPS, is host is specific, so it's going to be on that computer. Protects the host after decryption because the NIP does not do it. So the network base doesn't protect um, after decryption because when it's passing through, the traffic is encrypted. It provides an application level encryption protection, and the limitation of HIPS or host based IPS is operating system dependent, so it depends on the operating system that you have. If you have Linux, Windows, Mac. Lower level network events are not seen. Host is visible to attacker, so the attacker knows what host base you have installed on your computer. For the network IPS or NIPS, it is cost effective, not visible on the network, so the hackers cannot really see it. Um, Operating system independent, so it doesn't matter what you have if you have Linux, Mac, or Windows installed on your computer. Lower level network events are seen, and the limitations of it, it cannot examine encrypted traffic. So that's why it is really good for you to have a host IPS and also a network IPS because you can protect the host after decryption because the network IPS does not do that and does not know whether an attack was successful. And if you have a host, you will know if it is successful or not. And now moving on, we're going to 6.1b modes of deployment. So inline, promiscuous, span, and tap. So now we are going to go over the inline. So this is how the inline works. When the Cisco AS Firepower module is configured in an inline mode, the traffic passes through the firewall policies before it is sent to the Cisco ASA Firepower module. And as you can see right here, um, coming from the outside, the VPN decryption, it goes into the policy firewall, and then the firewall just sends it to the firepower inspection, and from the inspection, it goes into the VPN encryption, and then it goes to the inside. And here's the steps that we just went over. So the number one is the outside host. So if IPsec of SSL VPN is configured, the incoming traffic is encrypted. Traffic, the incoming traffic, encrypted traffic is encrypted. So it is encrypted on the number, oh, that was for number two. Yeah, number two right here. For number three, the firewall policy. So firewall policies are applied to the traffic. If the traffic is compliant and allowed by the firewall policies, a copy of each packet is sent to the Cisco ASA firewall module. So it copies it and then it sends it down over here. And the security policies or is determined to be malicious. The Cisco ASA firewall module can be configured to alert the admin, but it does not block the traffic. As you can see right here. If IPsec, for number five, if IPsec or SSL VPN is configured, the outgoing traffic is encrypted. There we go, encryption. The network traffic is sent to the network, and that's the last part. So that's how the inline works. And the inline works is that it sends, when the ASA gets it to the firewall policy, the policy sends a copy of the IP packets to the firewall inspection, and then it sends it to the VPN encryption if it needs to get encrypted, and then it goes to the inside network. So tap versus span. So a span, meaning switch port analyzer, is a term that describes when you mirror a port or copy the contents of traffic heard on one specific port and copy it to another port so a program can analyze the traffic, as in SolarWinds or Wireshark could do that. The difference between span and tap is that as simple as span is software-based snooping and tap is hardware-based snooping of traffic. So they both do the same. It's just the span is a software and tap is just a hardware-based snooping of traffic. And they both achieve the same goal. And now we're going to go over the IPS terminology. When deployed in real environments, security controls such as IPS may produce erroneous decisions either because of their misconfigurations or because of the environment, in which the legitimate activity may resemble malicious activities and vice versa. All decisions made by security controls can be classified as one of the following. So true positive, something that you want. The security control, such as an IPS sensor, acted as consequence of a malicious activity. This represents a normal and optimal operation. So that means that we got malicious traffic and it was stopped. And when you have a true negative, it's when the security control has not acted because there was no malicious. So nothing happened and it did not act. That's a true negative. Okay. True positive is when you get a malicious and you stop it. True negative is when you don't get anything and you don't get a virus or a malicious activity and you don't do anything. A false negative is when the security acted as a consequence of a normal traffic or activity. Okay. So a false net positive means that it detected that it was a malicious activity, even though it wasn't, but the firewall still acted on it. And here's the one that you don't want to have, a false negative. The security control has not acted, even though there was a malicious activity. So you have to remember this for the CCNA security. True positive is whenever the firewall acted on a malicious activity. True negative, nothing happened and no malicious activity occur. False positive is whenever the ASA acted, but there was no malicious activity. It was just normal traffic. And false negative is whenever the firewall did not act it or the IPS module did not act it, and it was a malicious activity. And when that goes through, if you have a host-based IPS, then you can stop it at the host-based IPS, which is really good if you have a network-based IPS and also a host-based IPS. So you should have both in your network. And this is it for this video, guys. I hope you guys enjoyed. I hope you guys learned a lot on this video. So we went over um, section 6, 6.1, and we went over the network base versus a host based IPS. A network being that it is in line in the network and the attacker cannot really see it. Host base is whenever you install a software like McAfee and the attackers they are able to see it. The host base is able to inspect the traffic after it's decrypted, and the network base cannot do that because the traffic that is passing through it is encrypted, so they cannot see it after it is decrypted. The modes of deployment we went into the inline is when they tap in the network line and a copy sends to the IPS module and they inspect it. Span is just a software-based snooping, and tap is a hardware-based snooping. The placement, we went over the placement and how they are positioned. We went over a couple of pictures. And false positive is whenever we get a malicious activity and the firewall acted on it. False negative is is when nothing occurs and we did not act on it. True positives is whenever we receive traffic thinking that it was malicious and we stop it, but it was normal traffic. True negatives is what you don't want to have. True negative is whenever there was a malicious activity on it and the network or the IPS module did not act on, and that's why it is good to have a host space because after it gets to the computer, we are able to detect it after it is decrypted and we can stop it there. So that is it for this video, guys. I hope you guys enjoyed. And if you enjoyed this video, go ahead and follow me on Twitter. Twitter changed um, the way Twitter looks, but go ahead and follow me on Twitter at CCNA Daily Tips, where I post a lot of stuff on the CCNA, CCNP, and CCNA security exam. And also go ahead and subscribe to my channel, CCNA Daily Tips. Thank you guys for watching. I'll see you in the next one. I love you guys. Bye bye.